Okay, after understanding what is critical region, the next thing we would like to understand is requirements to handle critical region. As we already said in earlier example, consider a fresh room as a critical region which can be accessed only one at a time manner. Let's see, as we have in current example, A, B, C, D are in waiting. This is because person X has already gained access to the critical region. So now, considering this example, there has to be certain rules and regulations which one needs to follow. Now what are these? Let's try to understand. The first and the most basic requirement which anybody would have under this situation is mutual exclusion. This mutual exclusion simply refers to one at a time access, which refers to ability of a system to provide only one person access of the needed data, file or a database. In current situation, it is very obvious that if somebody has gained access, others cannot access at the same time, so they need to wait. The second thing is, again, as per the example, clearly understood, that is bounded wait. When we talk about bounded wait, means what? Approx time to wait. Why we would wait? Because we are waiting to enter the critical region. The system is supposed to be pretty simple. There has to be a limit which would decide the amount of time which at the most a process has to wait for entering a critical region. Considering example, if person X takes good amount of time, obvious A, B, C, D would create an issue. There will be a time where person X has to come out. This is decided, or rather it is pre-decided by the system. Behind this is pretty simple. There will be a time, even if person X has not finished the task, it has to move out of critical region. And after this, access would be granted to A. So now, in this case, what would happen? A from here would enter the critical region, and now waiting would be D, C and B. So bounded wait has to be there, which would decide amount of time at most a process should wait to enter critical region. Third requirement of critical region is a progress. Progress simply refers that the processes which are inside should help to decide who would get insight from the outside. Basically a bit confusing to say. See, there are two factors. Critical region. When a particular process X is within the critical region, it is sure that after finite amount of time, process X would exit the critical region. Under that scenario, other processes which are waiting, let's say process A, process B, process C, X should help to decide A, B, C who would be gained next access. So basically progress is to help waiting process to enter critical region. This is generally done by algorithms. So there are series of algorithms who would decide, or rather which would decide out of C, B, A who should enter. We already talked about some of the algorithm earlier, scheduling algorithm, that will again can be used under this scenario.